Welcome back, everyone. So this is the last problem set that we will be looking at in the categorical data, right? Categorical data unit, and this is called conditional distributions. All right, so let's begin. We looked at marginal, and now we're doing conditional. Leon is interested in the relationships among geographic region and political affiliation. Okay? Especially this is pertinent in an election year like we are in right now, correct? Leon collected data about the political parties of U.S. senators at that time and the regions of the U.S. that they represent. His results are in the table below. So here we have a two-way table. This is a two-way frequency table, and we can clearly see that one category is region, and the other category is political party, right? Political affiliation. All right, and we are also given the totals. So here it says which graph displays the conditional distributions of region for each political party. So for each of these political parties, right, there's three. For each of them, which graph displays the conditional distributions of region? So for the Democrats, we should have a graph for all these regions. For the Republicans, we should have another graph. And for the independents, we should have a third graph, correct? And so let's take a look. So here, this represents the relative frequencies of the political parties in each of the regions. Okay, this is the political parties in each of the regions. Here it says they want the conditional distribution of region for each political party, correct? So this is sort of backwards, I think. This looks more like it here. For each of the political parties, these colors relate to the region. Okay, so I think B is the correct answer, not A. Again, A is reversed. So let's pick B, and sure enough, that is the correct answer. Okay, let's do the second one. James is interested in the relationship between weather conditions and whether the downtown train he sometimes takes runs on time. Again, we've seen this before, right? But now it's going to be a conditional distribution question. And for a year, James records whether each day is sunny, cloudy, rainy, or snowy, as well as whether this train arrives on time or is delayed. His results are displayed in the table below. Give the conditional distribution of weather conditions for delayed trains. Okay, so here are the delayed trains, and there are 35 times in a year the train was delayed. And he wants to know what the conditional distribution is for distribution of weather condition for them. So out of the 35 days that it was delayed, what percent were on sunny, what percent were cloudy, what percent were rainy and snowy? So we're going to have to divide each of these values by 35, correct? So let's do that. Okay. So we're going to do 3 over 35 first. 3 divided by 35. Okay. And I'm just going to do the numbers first. Okay, so 5 divided by 35. And let me see if I can fit all of them in the screen. Divided by 35. Okay, so let me write the first one before it disappears. Round your answers to the nearest tenth of a percent. So 1, 2, so it looks like it's 8.57, so it's 8.6, right? Looks like the first one's going to be 8.6. 8.6. And the second one is 1, 2, so the second one looks like it's going to be 14.28, so 14.3. Okay. Third one is 42.85, so 42.9. Okay, and then the last one. Okay, it looks like it's 12 divided by 35. So that's going to be 34.28, so 34.3. 34.3. Okay, and that is correct. Okay, so let's take a look at the next one. Again, we've seen this before, right? So I'm not going to read it for you because, again, we had this problem previously. Again, it deals with region, right? Region of the United States and political parties. So here, give the conditional distribution of political party for the northern region. Okay, so for the northern region, right, there are 22 senators in the for the northeast region. Sorry, there are 22 senators in the northeast region, and of those 22, they want the conditional distribution of the political parties. So of the 22, what percent are Democrats, Republicans, and Independents? Okay, so let's calculate that. It's percent, so it's going to be 14 over 22. So let's do it. All right, 14 over 22, that gives us that. And then we're going to have, excuse me, 7 over 22. And then, of course, 1 over 22. So for the Northeast, just lost it, it's going to be to the nearest tenth of a percent. So 63.6 looks pretty good. 63.6 for the Democrats, and then 31.8 for the Republicans. 31.8. And then finally for the Independents, it looks like it's going to be about 4.5, right? So let's write in 4.5. And that is correct. And then now finally, last problem. Laura surveyed all of the 11th grade students at her school about the number of languages they speak and whether or not they have allergies. Here are results. So the number of languages that her 11th graders speak, that her 11th grade students at her school speak, and whether they have allergies or not, right? Their allergy status. Which of the following interpretations are correct? Well, let's take a look at them. A, if a student has no allergies, so these are the students that have no allergies, it is unlikely that the student speaks more than 2 languages. Okay? Well, and it says choose all that apply, right? So here are all the students. There's 44 students that have no allergies. And of those 44, it looks like only two of them speak more than 2 languages. Okay, and the rest, they speak either 1 or 2. So if a student has no allergies, it is unlikely that the student speaks more than 2 languages. Yeah, only 2 out of 44 speak more than 2 languages for those students who have no allergies. So that sounds pretty good. Okay, let's take a look at the second one. If a student speaks 1 language, so there are 53 students who speak 1 language, correct? The student is more likely to have allergies than to not have allergies. Well, that's the reverse. Out of 53 students, 25 of them have allergies and 28 do not. So this statement is actually reversed. The student is more likely to not have allergies than to have allergies, right? So that is reversed. Let's take a look at statement C. If a student has no allergies, so these students, these 44 students, if a student has no allergies, it is about equally likely that the student speaks 1 language or more than 1 language. So let's take a look. There are 28 students who speak 1 language, but there are now 14, 15, 16 students that speak more than 1. No, that is not true. Okay? So I think there's only one correct answer here, and that is correct. Okay, guys? All right, take care.